Hello everyone, thank you for signing in and watching my live stream. This is Algebra 1. Today we're going to talk about writing and reading expressions, mathematical expressions. I'm Mr. Matt and this is Dr. Tot. He gets a cookie before each session. Last time we talked about a few vocab words that we need to know in mathematics. They're going to come up again and again and again. We talked about sum, difference, product, and quotient, and how those things get translated into mathematics. We're going to work more on that today. Let me share my screen with you. And so just a vocab recap. Remember that the sum, that's a little bit wide, isn't it? We can do better than that. Let's go with this one. So remember that the sum is the answer to an addition problem. So it implies addition. The difference between or among values implies subtraction. It's the answer to a subtraction problem, in other words. The product of values implies multiplication. And the quotient is going to imply division. Okay, so the sum of values is all of the values added up. The difference of two values is one minus the other. The product of two values is one times the other. And the quotient of two values is one divided by the other. Now, it's very important, I think, to point out at this point that remember addition and multiplication are commutative. They are going to order doesn't matter with addition and multiplication. You can switch the values around and you'll still get the same result. That's not true for subtraction and division. So for addition and multiplication, 3 plus 5 is 8. 5 plus 3 is also 8. 3 times 5 is 15. 5 times 3 is also 15. So you can see you can switch the numbers around and you still get the same result. That's not true for subtraction or division. Take the same two numbers, 3 and 5. 5 minus 3 is 2. 3 minus 5 is negative 2. Those are two different numbers. If you take division, 3 divided by 5 is 3/5. 5 divided by 3 is 5/3. Those are also two different values. So you can't switch the order up with subtraction and division. You have to make sure that you get the order right. So if there's any questions, please let me know. I want to jump right in, and I'm going to give you 4 minutes. I'd like you to translate the following phrases into algebraic expressions. Okay, so let's look at these two problems. The first one says 12 divided into two groups plus 8. Now, as we'll learn later in this course, there is a more specific way. There might be a little bit of ambiguity, a little bit of confusion into what you need to do first. If you're ever confused about the order, make sure that you follow PEMDAS, right? The order of operations, parentheses, exponents, multiplication, division, addition, subtraction. So make sure that you're doing the multiplication or the division here first and then the addition. Later on, we'll introduce a phrase called the quantity, which in mathematics we use to specifically indicate what is grouped together and what is separate on the outside. So here, the plus 8m is on the outside of this whole thing because you're doing the 12 divided into two groups first. So if we have 12 divided into two groups, that's going to be 12, put a parentheses here, 12 divided by 2 plus 8m. Now 12 divided by 2 is 6. You cannot add 6 and 8m. In order to combine terms, they have to have exactly the same variables to exactly the same degree. The 6 is a constant value. It doesn't have a variable attached. The 8 is a 1 power variable or a variable to the first power. There's implicitly an exponent of 1 here. When the exponent is 1, we don't write it. So because it doesn't do anything, anything to the first power is that same something. So here, when we say 8m, it's really has a different power than the constant. We would consider the constant to have a power of 0 because it has no variable attached to it. So these are different power monomials or different powered values. So we can't combine them. So this is going to be our final answer, 6 plus 8m. And you don't need to include the 1 as an exponent because it's implied. If the exponent were any other number than 1, you would need to include it because that would cause that would change the value. That would have an effect, a mathematical consequence or impact on the value. Number 2, we have 21 divided into 7 groups. So 21 divided by 7 minus 2. So 21 divided by 7 is 3. 3 minus 2, 3 and 2 are both values with no variable, so we can combine them. 3 minus 2 is 1. So the second expression is going to simplify into 1. If you have any questions, please let me know. Otherwise, let's take a look at these two problems. I'm going to give you 4 minutes. I'd like you to translate the following expression into phrases. So just the opposite of what we were doing in with the last two problems. Okay, so if we look at these two questions, the first, we could translate this guy, so we're adding these two together, so we know when we add two things, two values, that's the sum of the two values. So we could describe this as the sum of 36x squared and 12y. And like I said before, we use the word quantity to say that that's all together makes up the numerator. So we're going to say quantity divided by 7x. For 2, we could describe this as 10 times c squared quantity divided by 3 times d squared. If you have any questions, then please let me know. Otherwise, let's try 2 more. So we're going to do the opposite now. So translate the following phrases to algebraic expressions. Okay, so let's look at these two questions. So the first, 12 more than 4 times 3j. So you're adding 12 to the product of 4 and 3j. Make sure that you pay attention to the order of operations, do multiplication before you do addition. So we have 4 times 3j, and we're going to add 12 to it. So 4 times 3j is going to be 12j, plus 2 is going to be 12j plus 2. So if you're ever lost at what you're supposed to be approaching first, make sure that you follow PEMDAS, the order of operations. Parentheses, exponents, multiplication, division, addition, subtraction. 2, 6 less than 5b times 7. So you're subtracting 6 from the quantity 5b times 7. So we're going to have 5b times 7 minus 6. Now it might be counterintuitive that the 6 and the 12, excuse me, this 6 and the, I'm sorry, the first one should be a 12, not a 2. I wrote 2 and I meant 12. My apologies. So it should be 12j plus 12. Now, why is the 12 and why is the 6 coming after these products? So because the wording makes it seem a little bit counterintuitive. It might seem as if it's you should take 6 less than the 5b times 7, but that would give you a positive 6 minus that quantity 5b times 7, but it's really the 5b times 7 less this whole finite amount of 6 units. So you need to take the product of 5b and 7, which would be 35b, and subtract away 6. If you have any questions, please let me know. I'll give you 4 minutes. Let's try these two. Okay, so number one, we're adding all the, first, there's many ways that you can actually describe these sentences. So this is just one out of many variations, but potentially we could say we're adding all of these things up. So we can say it's the sum. We could say the sum of 3w squared 5w and negative 2. You could also describe it as just 3w squared plus 5w minus, or you could say less, but minus 2. Those are both valid ways. There could be others as well. There's not one exact way to word this. It's a little bit subjective. But as long as you have the concept down, notice that when we describe the sum of the three things, I have to include the 2 with the characteristic or the descriptor of negative, because sum implies addition. So I need to make sure that I indicate that that's negative, whereas if I say minus, then I don't need to say negative 2, because it's implied that the operation is subtracting, right? Subtracting a positive is the same thing as adding a negative. It's just every addition or subtraction statement, each number has its own sign, and then you also have the operator. So you have the sign of the first number, the operator, whether it be addition or subtraction, and then the sign of the second number. So adding a negative is the same exact thing as subtracting a positive. And that's what these two alternatives are describing or pointing at. The second one, oh, let me get my pen back. We could describe, same type of thing, really. So we could describe it as the sum of 2xy 4x squared y and 6xy squared. Or you could have also described it as 2 times x times y plus 4 times x squared times y plus 6 times x times y squared. Those are exactly equivalent. Just notice how much longer the second statement is. So you can, I'm sorry, let me move that so you can see it. That would be helpful. So notice that these are exactly equivalent statements. And if you have any questions, then please let me know. If not, let's look at the next two problems. So I'll give you 4 minutes. Okay, so for this first question, 3C more than 8 separated into 4 groups. So we're going to have 3C more than 8 separated into 4 groups. First of all, we have 8 over 4, and then we'd have plus 3C. 8 over 4 is 2, so this would turn into 2 plus 3C. That would be the same exact thing as 3C plus 2, because remember, addition is commutative, so the order doesn't matter. You can flip them around. Number 2, 4 times the sum of D and 2. So the sum of D and 2 has to, that implies parentheses, that implies that it's its own quantity. So we're going to have 4 times D plus 2. Make sure that you can't add the D and the 2 together because one's a variable and the other's a constant. But you can distribute that 4 within the parentheses there. So the 4 is going to be applied to the D and to the 2. So this is equivalent to 4D plus 8. If you have any questions, please let me know. I'll give you 4 minutes. And this will take us up to the end of class today. This will be the last problem set, and we'll pick back up on Friday. Okay, so this first statement here, we could express either as the sum, I should have an article there, let me say the sum of 4ac 2b squared and negative 3c squared. You could also write that out longhand. Let me do this in another color. So we could say 4 times a times c plus 2 times b squared times c minus 3 times c squared. Okay, so either one of those would be acceptable. And then for the second problem, we have, we could describe this as the product of 14q and 7r quantity, get this down here, divided by, so that means the whole thing divided by the product of 3h and 5j. And you could have also written that out longhand, so you literally could just say 14 times q times 7 times r, quantity divided by 3 times h times 5 times j. Either of those are exactly equivalent expressions. If you have any questions on anything that we've done today, then please let me know. Otherwise, we're going to sign off there, and I hope you have a wonderful night. Please remember to like, favorite, and subscribe. I'm trying to get a permanent YouTube channel, so we need 100 subscribers, but we're going to pick back up on Friday with some more applications of these concepts.